Okay, so this is a text completion module that's been given a prompt to assess parts of speech and monosemantic relations, given a provided text. In this use case, transcripts from voice notes. So the instruction is to analyze the given text by tagging each word's part of speech using tags and identifying monosemantic relations, for example, coreference, synonymy, denoting those in tags as well. Provide the tagged text within denoted tags and a numbered list of relations within the relations tags. If the text is longer than 800 characters, generate a Ruby script that will segment the text into smaller chunks of text. That might be a little redundant, but, and then it's provided the text through a variable, which is then populated in a freeform text field. So testing this out with Gemini 1.5, it produces, on first look, and on second look for that matter, a nice clean method to pass text to, that will split by a single space, or one or more spaces, and then for each word, along with its index, it'll return whether or not it's a proper noun, cardinal number, verb gerund, verb past tense, adverb, coordinated conjunction, and by default, it'll tag it as a noun. And then it will assess the monosemantic features by comparing where the word is placed in relation to the previous word, and that's based on how it sees it in the index. And so here, the context gets a little confused, so then check if the chunk size exceeds 800 characters, if chunk length is greater than 800, or the index length is, or the index is equal to the word's length. I'll have to get to that. So actually what I'll try here, it does provide an explanation. Segmentation, the script splits the text into words, it iterates through the words, adding them to a variable labeled current chunk. If current chunk exceeds 800 characters or reaches the end of the text, it wraps the chunk in within sentence tags, increments the sentence counter, and resets the current chunk. For each word, it applies a set of rules to determine a likely POS tag. The rules are simplified for demonstration and can be expanded for accuracy, which for that we would use Ruby Spacey, most likely. Number 3, it looks for potential core reference from relationships. In the simplified example, it identifies cases where a proper noun follows, quote, the, or, quote, this, assuming it might refer to a previous mentioned entity. And for the output, the final tag text and identified relations are wrapped in tags and returned as a JSON string. Now what I'll do is, I feel inclined to save this because it seems, well, it is valuable in the sense of I can't quantify an exact time how much effort this saved, but it's significant. But what I'll do is to get to the point of reproducing these results, I try to resist the urge to save the initial results, as I think it more naturally leads back to the process of being able to reproduce it when, and this happens often, when rerunning this, a different result will, a less, how do I say, satisfying result. And then it's kind of a frustrating adventure from there to figure out, okay, what went wrong. And conventional logic will, and for good reason, would say, well, save this and then then analyze the parts of it that worked. And it's just a different methodology, a different way of, an alternative way of going about this. As I find that doing this, as work, it's well, I'll leave it at this, that it's either way, it's the process isn't perfect. But anyways, so okay. So that's been updated. Let's see if it perfect. Exactly what I was talking about. So this time it's for the example that it's giving, it's inserting the entire I don't think there's a stop button on this. Please wait. Okay. So I might see if I can contact somebody on the Diffy team to include a mechanism to stop undesired output, because this is lengthy. Okay, so it ends up cutting off. So I'm inclined to, at the moment, to resolve or work around this kind of thing by appending the instruction with do not include the previous text, but that's definitely not, that's ambiguous as far as the language model will be concerned, probably half the time. Okay, so I reworded it to, if the text is longer than 800 characters, generate a Ruby script that will accept text, or the text, via an API call to then segment the text into smaller chunks. So that's a good response, as that is more in line to what is already in place for this sort of thing. So as it stands right now, if this Sinatra instance is running data or text sent is, well, there's a problem that I'm sort of stuck on using the Ruby Spacey library, where if I make a call to the Spacey module directly from the API instance, it exits with a stack trace. Not sure why. So as a workaround temporarily, I call it through the shell using backticks, which, yeah, it's a workaround for now. But that gets passed, so that's what this is, the feature extraction, where it will utilize the Spacey model to extract dependencies named entities, as well as provide an analysis, or, excuse me, I don't know if analyzer is the best description there, but it takes the sentences and maps the text to the part of speech tags and extracts structures that fulfill this requirement of subject, verb, object. So I figure if I just run this a few times and see if the results are consistent, that should, I mean, these are all great examples, which gets me really excited. So, so if I do a Google search, this this used to be the way. Any of these examples, while they may be somewhat similar, they're not nearly as specific to the use case as this can now produce. So this is a nice little suggestion. Call an external part of speech tagging API or use a gem like endtagger. For this example, let's assume you've used an API and got your response. So this is a nice example. If, and then it provides an array of he, she, it, this, that, these, those, include, so basically it's trying to match whether the word is one of these. And let's see. Oh, and again, it bases it off where it is within the index. To me, it's not exactly clear how it determines that. But I believe that would require some study into statistics or probabilities or something like that. But that is actually not entirely necessary to know specifically. Again, the explanation is apt. So what I'm trying to work into my habits is I feel inclined to save this because again it's a great example, and especially when first starting out, the more good examples you have, the better off you are. But personally, I'll find myself doing that more than I should, in the sense that then organizing all those examples becomes an overwhelming task. So that's again, that's a habit that is mostly conditioned on the classical search method of query, scan, repeat, where ideally I can just do this all day and have it generate interesting examples. So now later, when I go back to this, all I have to do is run this. It's like, for example, this right here, using the rewind method, I've been having some difficult time processing JSON through an API instance like this, and so now I'm interested in seeing what that looks like. Now, for something like this that seems to now be producing consistent, desirable results, so with Agenta, this is just the base configuration that that hasn't been adjusted yet. So I expect different results. In this case, it's using the Cohere command plus. So I notice right away that it blatantly disregards my explicit commands. and make some things up, I guess. Huh. So what I think it interpreted was providing an example of what the eventual desired output would look like, which that's interesting. MDAV0. So there's that. Yeah. Noun, verb. Huh. So you can see Google is, excuse me, the Gemini model is a bit less rebellious. So working with, an API that allows for these are all the basic subscriptions or services, with an unlimited context window. This is fine too, but working within a limited context window, this adds up pretty quickly. So you can see here, it's pushing 9,000 characters, humming along. Oh, there we go. So it eventually cuts off at 8,822 characters. So that's a perfect example. So like here, the Claude 3 Opus model, it's going to tag the entire transcript, which is going to sort of eat into my budget a little bit, which is fine. That's what it's for. Oh, so that's interesting. So it looks like then it tagged as much as it could up to 800 characters, and then it determines the text is longer than 800 characters. So here's a Ruby script that will accept the chunk via an API call and segment it into smaller chunks. Script utilizes Sinatra framework to define an API endpoint and accepts post requests with the text to be analyzed. It splits the text into 800 character chunks, runs the point of part of speech tagging and relation identification on each chunk, placeholder functions for now, and returns the result as a JSON object. The actual part of speech tagging and relation identification implementations would need to be filled in. So that was unexpected. I like how it phrases it here. So here is a script. The text was 800 characters, so here's a script for you. It's a pleasant sentiment. So I'm gonna try something here. In the ideal, this would be then committed to version control. So, but anyways, I'll take the risk here for the sake of time. And what I'm going to do is switch the order. Oops. Doop, doop, doop. So with, that's interesting. So phrasing it this way, the Gemini model produces only the example script without the explanation. Cohere, that just cuts off, and so the phrasing has then created a sort of interference that is just tagging everything as part of speech, part of speech. The Claude 3 Opus model tags what appears to be 800 characters. So as I see here, it doesn't cut off. This shouldn't cut off here any moment. Yeah, there it goes. So what I think I'll do in the spirit of mindful token allocation, is that I'll debug this to ideally produce the same result as the Gemini model in this case. If I can reproduce that in the Cohere model, I'm thinking that I can then apply that to the other models as well. Because this one seems to completely disregard. Actually, now that I'm thinking about it, when this finishes, one more thing that I'll try is to put this instruction after the text. AV0, part of speech. Adverb, maybe? So yeah, so it looks like it's not one of the standard ones. So then I would just prompt the model to explain that. This looks like an interesting paper. Don't mind me for a moment while I distract myself. Many of the chapters in this book include short summaries of psychological research on human processing. Of course, understanding human language processing is an important scientific goal in its own right and is part of the general field of cognitive science. However, an understanding of human language processing can often be helpful in building better machine models of language. This seems contrary to the popular wisdom, which holds that direct mimicry of nature's algorithms is rarely useful in engineering applications. Really? That seems very counterintuitive. I guess I just assume that most, if not all, of our behavior is as a result of the natural algorithms that are that dictate life's behavior. For example, the argument is often made that if we copied nature exactly, airplanes would flap their wings. Oh, I see. Sure. In that specific instance, right. That's absurd. So, for example, birds are made of organic material, where airplanes are made of, not organic material, various metals and plastics and such. So, anyways, that's that's one part of the. I mean, that right there sort of highlights a frustration in working in this field, as arguments and contentions such as that. But that's kind of why I'm drawn to material like this, is that, with language models now, we can analyze our speech to point out things like the fact that that's a ridiculous argument, for the point of ignoring, the tendencies of natural algorithms. So this actually looks like great information that I would like to incorporate into the knowledge base. It's well structured. It seems to contain a comprehensive overview of various aspects of linguistic analysis, morphological phrasing, to the segmentation, stemming, I always enjoy trying to say this word, lemmatization. Oddly enough, it has little to do with fruit. It touches on inflection and compounding. I'll keep that open for now. I didn't realize the title of this this is labeled as an introduction to natural language processing. All right. Oh, yeah. All right, so I'll have to marinate on this for a minute to adapt this. Although I will say I'm noticing some tags here that I haven't seen before, um, so I can tell that Gemini uses Ruby Spacey, but Cohere seems to use something else. Or not, I'm sorry, not Ruby Spacey, but Spacey-like. Well, yeah, most likely. Yeah, I'd have to ask them, but labels is a preposition, or yeah, PRP, VBZ, WRB, JJ, and have to do some looking into that. Okay, so is labeled as an adverb, and MD, pronoun auxiliary D, looking to adapt this instruction, looking verb, part, verb, I forget what ADP is. Very interesting. So I assume that's cut off by now. Yep, okay. So converting this into a workflow, I'm actually going to duplicate this. Okay, so if we convert this, so I might have to convert the string into an integer. Or maybe, so with this, it looks like I'll have, it looks like I'll have to use, I'll have to pass this through as a Jinja template that converts the string to an integer, and then pass that to a variable assignment. But that doesn't accept, so if I change this back to string, then the output from the template is available. Okay. Well, actually, I forgot about this module. Well, I'm not immediately sure how to do this in Python. What it would take here is the text as an argument and run a word count. I assume with a system file module and or library, and then output the result as an integer.
You want to write a Python program that takes a text as an argument, runs a word count using the backquote collections backquote module, and outputs the result as an integer. Here's an example code that should do what you're looking for. Backquote 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 Python import collections import sysdef word underscore count, text, hash split the text into individual words equals text. Split, hash use a counter from the collections module to count the words word underscore counts equals collections, counter, words, hash return the total number of unique words return len, word underscore counts, if underscore name underscore
I'm not sure about this comma here. So let's see. Okay. Not sure. I'll have to do some debugging. Oh, failed to list dependencies. Please check if the Sandbox service is running. So I'll have to do some digging into that service. Whoops. But the basic logic is in place.